Okay, so we've got to put some forces on this diagram. So we're going to have tension on each of these. And then this one will have a weight of 0.6 g, and this one will have a weight of 0.2 g. And when we let go, this is the heavier particle, so this is going to accelerate that way. So I'm going to do F equals ma for both of these, and then we'll do some simultaneous equations. So for P, as it's going this way, this will be the positive force, and this will be the negative force. So I have 0.6 g minus T equals 0.6a. Now for this one, it's going that way, so these things are positive, so I've got T minus 0.2g equals 0.2a. And we're going to do simultaneous equations with that. So if I add these together, minus T and plus T cancel, so I've got 0.6g and minus 0.2g, which is 0.4g, makes 0.8a. So A is going to be 0.4g over 0.8, so that's a half, so that's 4.9. Just realised that's part 2 and I was meant to be getting tension first, but never mind, let's go back and plug that back into here. So I've got T minus 0.2g equals 0.2 times 4.9. So T is 0.2 times 4.9 plus 0.2g, and I'll put that in my calculator. So that's 2.94 newtons. Okay, so that's A and B done. I'm just going to rub this out and we'll do part C. So for part C, we need to find when it hits the ground. So we need to find how far it goes and how fast it's going at the end of the 0.4 seconds while it's still attached, and then the rest of the time it will move freely under gravity. So just looking at P here, so it started 1 meter above the ground and it was accelerating while it was attached at 4.9 meters per second squared. So that's A. U was 0 because it was released from rest. T was 0.4, and I need to know how fast it was going at the end and how far it went to know how far it's got left to fall. So to get V, first of all, I'm going to do V equals U plus AT. So I've got 0 plus 4.9 times 0.4. Which is 1.96 meters per second. And then how far did it go in that time? I would use S equals UT plus half AT squared. So U was 0, T is 0.4, sorry, 0 times 0.4 is 0, plus a half times 4.9 times 0.4 squared. So that's 0.392. So that's how far it fell in 0.4 seconds. To find out how far it's got left to fall, I'm going to take that away from 1. So that's 0.608 meters left to go. So during this time, the string has broken. So it's falling freely under gravity, so A is 9.8. The distance we've just established is 0.608. At the time where the string breaks, so that's where I'm now starting from, it was travelling at 1.96 meters per second, and I want the time. So SU, A and T, I need to use S equals UT plus half AT squared again. So I've got 0.608 meters equals 1.96 t plus 4.9 t squared. Move all over to that side. And put it in my trusty calculator. And we get 0.205 seconds, and I'm imagining the other one is not sensible. It is not. And this last part, if the string is inextensible, then the tension's constant throughout, so the acceleration on both of those particles is the same.